We've spent a lot of time discussing, solving, and graphing linear equations, which are first-degree equations. Today we're going to start looking at quadratics, which are second-degree equations. And a quadratic creates a graph that's called a parabola. And it's a U-shaped graph, and it can open up or it can open down. If the parabola opens down, then the vertex or the turning point is at the lowest point of the graph. And we usually call this a minimum. If the parabola is opening down, then the vertex is going to be at the highest point and it will have a maximum. Regardless of whether it's a min or a max, all parabolas are in the form of y equals ax squared plus bx plus c. Now you could be missing a b or a c, but you can't be missing a, because if you're missing an a, then you're going to be missing your x squared term and it will actually be linear. If the a is positive, then your parabola will be opening up. If it's opening down, then your a value had to have been negative. Notice that it's less than 0 or greater than 0. Your a cannot be equal to 0, or else you won't have a quadratic anymore. All quadratics, whether they're opening up or down, have something called an axis of symmetry. So all parabolas are symmetric. Think of when you were making hearts back in kindergarten. You folded a piece of paper and you cut a heart out, and then you opened it up so you had two equal sides. A parabola is kind of like that. If you were to fold your parabola in half, you had this line going right up and down the middle. That's our axis of symmetry, and sometimes we just call it a line of symmetry. It is where you can reflect one side of your parabola over that line to the other, and it will look exactly the same, just like when you opened up your heart. We'll want to find the axis of symmetry first when we want to start graphing these, when we graph them by hand. The axis of symmetry always goes to the vertex, so once we have the axis of symmetry, we're going to be able to find the turning point. The equation for the axis of symmetry is x is equal to a negative b over 2a. So we're finding a line within that quadratic, a vertical line. The a, b, and c, even though this specific equation doesn't use c, come from the formula for the standard form. So it's a negative b, or the opposite of b, divided by 2 times a. So if I wanted to find the axis of symmetry for 3x squared minus 18x plus 7, it would be a negative 18, or a positive 18, over 2 times 3. And 18 over 6 is 3, so my axis of symmetry is at a 3. If I wanted to find the vertex for a negative 2x squared plus 8x plus 3, knowing that the axis of symmetry always goes through the vertex, I can find that axis of symmetry first and then use that to help me find where the turning point is. Once we find that x value, we can plug it into the y equals formula, into the original equation for x, and find out what y is. So let's first find the axis of symmetry. A negative 8 over 2 times a negative 2. So negative 8 divided by a negative 4 is 2. Take that 2 and plug it back into the equation. Plug it into the negative 2x squared plus 8x plus 3. Everywhere you see a 2. So I'll have negative 2 times a 2 squared, which is 4, plus 8 times 2 minus 3, and then y is 5. So my vertex is at 2, 5. And I know that this vertex is a maximum. Since my a value is negative, that means my parabola has to be opening down. Where we're going to graph these by hand, we're going to do this in 3 steps. The first thing we're going to do is find the axis of symmetry. We're going to use the equation x equals negative b over 2a. We're going to take that value and we're going to plug it back into the equation to find the vertex. Once we find the vertex, we're going to figure out what the shape of the parabola is by picking 1 or 2 numbers lower than the vertex, that axis of symmetry x value, and 1 or 2 higher. Now, it will create a symmetry, so once you find one side, you can kind of count to the other side, but not all axis of symmetries are nice. They're not always at 2 or negative 5. They could be at 0.75 or 1.3. So it's best to just find 1 or 2 points and not rely on the symmetry. So let's look at an example. I have y equals a 2x squared minus 4x minus 1. A is 2, so he's positive, so I know this parabola is going to be opening up and it will have a minimum. B is a negative 4, C is a negative 1, even though we don't need that right now. Let's first find the axis of symmetry. The formula is a negative b over 2a. So negative 4 is a positive 4. You just flip that sign. And then 2 times 2 from the a is also a 4. My axis of symmetry is at 1. I know that axis of symmetry has the turning point on it. That is the x-coordinate for the vertex. So now I'm going to take that 1 and I'm going to substitute it into the original equation. So y equals a negative 2x squared, where x is a 1, minus 4x. Again, x is still 1, minus 1, and I get out a negative 3. So my turning point is at 1, negative 3. Now what I want to do is find out, well, what's the shape of the parabola? I know where it's changing directions, but how wide or how narrow is it? So I'm going to pick some values, some a little bit to the left and some a little bit to the right. So I went ahead and I picked negative 1, 0, 2, and 3. One by one, I'm going to plug in those x values, crunch my y value out, and then I'm going to plot the point. So if I plug in a negative 1, I get out a 5. If I plug in a 0, I get a negative 1. 2 also leads to a negative 1. 3 leads to a 5. Now that I have all my points along with my vertex, I'm just going to connect it, and there I have my parabola. Now, these are pretty easy to graph by hand, but we can also graph them in a calculator. So I'm going to go to my y equals and type in my equation. So negative 2x squared plus 8x minus 3. And when I hit graph, there he is. Now you may or may not see it right away depending on what screen you have. So hit zoom and then zoom standard or Z standard so that you can get back to the 10 to the negative 10. And there's a picture of my graph. Now if I want to see where this vertex is, I can say second calc and pick a min or max. But you have to pick the right one. I know that this is a max, so I'm going to go down to 4 and hit enter. Now I have to pick a left bound. Move it a little bit closer so that it's right a little bit to the left of where the max is. Then I'm going to move the blinker so that blinky is a little bit to the right and hit enter. And then you have to take a guess. It doesn't have to be a very good guess. It just has to be in between the two bounds. And when you hit enter, it will eventually find it. 2, right? 1.999999 is 2. And y is 5. And there we go. So it's not too bad. Now the other thing that you could do with the calculator, that just like you can use it to graph lines or you can use it to model lines, I could use this to graph my quadratics, or I can also use it to model quadratics. So if I go into Stat Edit and put in some data, I just happened to choose these values before the video began, I can look at this scatter plot, right? I go into second y equals, and I'm going to turn this plot back on. I'm going to go into regular y equals and clear this out. So now that when I hit graph, well, I'll see a scatter plot, most of it. So let me do zoom stat. And you can see that this does look pretty nicely like a U. It's a little bit more like a V, but it's a pretty nice U-shaped graph. And if I wanted to know the equation to model this, I can go back to the main screen by hitting second mode, and then hit stat, over to calc, and then underneath line reg is quad reg. Just hit enter twice, and it will give you your model. So it will model lines, quadratics, and a couple other ones that we'll look at later on in the semester.